Hey there, in this video we're going to jump into factoring a quadratic trinomial when a does not equal 1. It's going to use the same steps as our snowflake method that we used before. Only difference is that a value, as we can see here in this example, oops, I'm still on a highlighter, that a value is not 1. So here's the tip. Always look for a greatest common factor first. Factor it out if you can. That's going to make your factoring a whole lot easier. So if we're reviewing greatest common factor, I'm looking at what can I divide all three of those numbers by. I think I can divide them all by 3. And how many x's do they have in common? This one's got 3, this one has 2. My last term only has 1. They all at least have 1. So I can say that my greatest common factor is 3x. From there, I'm going to actually factor it out, which means divide by it. So I'm going to divide each term by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. I'll come back and do the x's in a second. Negative 18 divided by 3 is negative 6. Now let's tackle those variables. Our first term had 3 x's. It was x cubed. It's multiplying 3 times. We factored out 1, so that means that there are 2 left. Our second term had 2 x's. We factored out 1. There is 1 left. Our third term only had 1. We factored out 1, which means there is nothing left. And now if we look at the trinomial that's inside my parentheses that I've underlined here, that is what we're going to use our snowflake method to factor. A is 1, B is 5, C is negative 6. And now we can set up that snowflake with my A times C being negative 6. My B is 5. That's 1x, 1x. I'm doing all of the inside factoring in red. Let's think what can multiply to be negative 6 but add to be 5. I'm thinking we got 1 and 6 or 2 and 3, but we want to add to be a positive 5. That's going to be a positive 6 and a negative 1. That adds to be 5 but multiplies to be negative 6. And then I can set up my factors here. I'm going to have x plus 6 and x minus 1. But what I cannot forget is that GCF out in front. So we're going to put that 3x. It's still there. All together, that is my answer. What we essentially did was we took this inside and we factored it into 2 pieces. That's what I'm underlining here in red. That, when you find a GCF first, could make your factoring a lot simpler when that A is no longer 1. Well, what about when there's not a GCF? Let's jump into it. Let's list our ABCs. A is 6, B is 11, C is 4. So that means we actually have an AC value. Now remember that's A times C. So that's going to be 6 times 4, which is going to be 24. This is new. This AC is new. We actually have an AC value now, so let's use it. I want to multiply to be 24. What's my B value? 11. I want to add to be 11. I actually have an AX now. That's 6x. That's 6x because I'm following my snowflake method. There's actually an A here. Let's look for those factors of 24. 1 and 24, 2 and 12, 3 and 8. Let's check it out. 3 and 8 is 3 times 8, 24. Yep. Is 3 plus 8, 11? Yes. So my 2 factors are 3 and 8. I'm going to write those in there just like we've been doing. But now when I look at my 2 fractions, I have to see if I can simplify them. So I've got 6x over 3. And then I have 6x over 8. Let's simplify those. 6x over 3 can be simplified to be 2x over 1, because 6 divided by 3 is 2. I made a little note here. You must have a denominator. That's why we've got that note there. 6x over 8 can simplify to be 3x over 4. And what we have in purple now is our 2 factors, which would be 2x plus 1 times 3x plus 4. That would be my answer, the 2x plus 1, the 3x plus 4. Because we simplified them if we can. If we don't simplify, we're not mathematically correct. Because if we remember, factoring is the opposite of multiplication. If I were to multiply these two binomials, I would arrive at my trinomial that I started with, only if I simplify my fractions. Let's do a couple more examples. Here the a is 2, the b is -1, the c is -6. That means my AC value is 2 times a -6, which would be a -12. Remember, we have an AC value now. And my a is 2, so that's 2x, 2x. I filled out my snowflake following my guide. And now I want to know the factors of 12, which would be 1 and 12, 2, 6, 3, and 4. Now, I got to multiply to be a -12 and add to be a -1. So I'm going to have to think of a combination of positives and negatives. Well, what about 4 minus 3? Nope, that equals a +1. Let's switch it around. What about 3 minus 4? That is a -1. And 3 times -4 does equal a -12. That tells me my two factors are a +3 and a -4. So let's look at these fractions. 2x over 3. Can we simplify that? Nope, it's in simplest form. Let's try 2x over -4. We can simplify that into 1x over -2, and we've got a note here. Keep the negative in the denominator. That's going to help you as we write our two binomials of 2x plus 3 times x minus 2. See where that negative, this negative here, became that minus there. That's why we want to put that negative in the denominator when we have one. And see, we just factored when a wasn't 1, and it only involved one more step of simplifying a fraction. Our last two examples here are some special cases. The first one's going to be a perfect square. So let's start factoring it like we usually would. A is 4, b is 12, c is 9. So a times c would be 36. Let's fill out our snowflake. 36 and 12. That'd be 4x, 4x. Now, as we list out our factors of 36, there are quite a few. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And we want to add to be 12. So what's the only pair that adds to be 12? 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12. So it's called a perfect square trinomial because both of the factors are the same. That's what makes it perfect, nice and neat and easy. So my factors are 6 and 6. Notice they're exactly the same. We've got one real fraction here, just 2 times. We've got 4x over 6. Let's see if we can simplify that. We can. We can divide both of those by 2. That can be 2x over 3. And we've got that 2 times. We've got it the first time and the second time. So the way we are going to actually write our answer is we're going to write it as 2x plus 3. But instead of writing 2x plus 3 again, we're going to use our exponents. That exponent 2 is our little note that we are doing 2x plus 3 2 times. And that is our answer. We've also got another type of perfect square where if you look at b, read this, 9x squared minus 100, something's off there. Where is the b value? It's not there. We don't have a single term with an x. The a is 9, got it. The c is -100, because remember we are following our ax squared plus bx plus C model. We don't have a something x. That B is 0, because if something's not there, it doesn't exist, it's 0. Let's fill out our snowflake like we know. The A times C is going to be 9 times negative 100. That's negative 900. Whoa, that's big. We can do it, though. That B is 0. We've got 9x. I'm going to zoom in on us. And now we've got to find a number that adds to be 0 but multiplies to be negative 900. And I've given you a real great hint right here. The only thing that can add to be 0 would be a positive and a negative of the same number. So since we know we're looking for the same number, we can take the square root of 900, and that is 30. That tells us, let's check, one will be positive, one will be negative. Is 30 times negative 30 negative 900? Yes. Is 30 minus 30 0? Yes. So we've got our two terms simply by taking a square root of the AC value, 30 and negative 30. The fractions seem really similar. One is just positive, one is negative, so let's simplify. 9x over 30 can simplify to 3x over 10. 9x over negative 30 can simplify to 3x over negative 10. And we are actually going to write both of those because they are not exactly the same. They are not exactly the same. So we do need to write that as 3x plus 10 times 3x minus 10. They are not exactly the same. One is positive, one is negative. And that's why we're going to look at these side by side. On the one on the right, one's positive, one's negative. The one on the left, they're both positive. That's why we have this exponent. We only have that when they're exactly the same. They're not here, so we've got two terms. I hope this helped you review factoring when we have an A value. Remember to always look for a GCF first. Use your snowflake. And make those special cases a little bit easier. We know we're looking for two numbers that are the same if it's perfect. If there's a B missing, take that square root of that AC value.